So 12 squared plus by 72 squared, square root. 73 inches per second squared. And the orientation, theta, is equal to inverse tangent 72 divided by 12. Okay, so 72 divided by 12 inverse tangent is equal to 80.53. Now, when a question like this comes up regarding the orientation, right, you have to view from here and sketch. So you have to sketch this way. And this is your what? 80.53. Are we clear? Okay. You have to draw for me that arrow over there. Okay. So we are almost at the home run. So now we will come back over here. Did we find acceleration at point B? Yes. If they want you to find magnitude, the absolute magnitude, you have to do the square root thing. Yes, you can. So if a question like this come out in your term test, I will tell you like either leave it in a Cartesian form or I want you to find the magnitude. So this is finding the magnitude. Yes. Yes. Because I provide that formula over here, yes? Yeah, I could not remember. Did I give? It's good that this were to test, is the formula sheet sufficient? Okay, so it's over here. Yes. Yep. Then yes, you have to. So if let's say you have a point down here, right? Then it will be different, right? Then you have the tangential and the normal, like what we had before. Okay. Right. So from here, we know what is going on in point B or point A now. So again, we can relate at point B. Okay. So point acceleration at point B is equal to acceleration at point A plus by alpha cross R B from point A, right? Minus omega squared RB from point A. Okay. So a good thing we have down here, or this is our omega AB, right? And we have proven that omega AB over here is equal to what? Is equal to 0. Okay. So from here, we know that acceleration at point B will be equal. Now, over here, you have to use the vector form, the Cartesian format. Okay. Minus 12I plus by 32J plus. Now, alpha, do we know alpha? Yep, alpha. No, we do not know alpha. Do we know alpha? I don't know. Did we find what is alpha? No, I don't know what is alpha. Okay. So I have not a clue what is alpha AB. So the alpha over here, did we assume clockwise or anti-clockwise? Okay. So our omega, I assume going in this direction, alpha, I will also go in that direction. Now, be very careful. Unless proven, do not assume anything that is equal to what? 0. Are we clear? Right? And unless you prove it, then go for it. If not, don't. Okay. So for this case, yes. Yes, I think that is a fair, because it can only move, not a fair, it's a very valid point. because the acceleration only can move what? Left to right, right? It's impossible to go what? Up and down. So when it's impossible to go up and down, means you can only go left and right, okay? So over here, then you will have minus alpha AB, okay, cross. So RB, or point A to B, we did that calculation, right? So now it's going to be positive. So it's equal to 4I plus by 6.928. So 4I plus by 6.928 J. Okay. So from here, and then this is equal to minus 0. Okay. So from here, you have minus 12I plus by 72J. K cross I is positive, so it's minus alpha ABJ. K cross J is negative, so plus by 6.928 alpha AB. And this is in KJ, and this is in I. And we also know that AB, so I don't know, no, I don't know. So AB, we assume it, so we are going to assume AB is going towards the left. Okay, so this is equal to minus ABI. Okay. So when we look at the J component, we have 0 is equal to 72 minus alpha AB. Okay. Yes, 4. Thank you. So over here, alpha AB is equal to 72 divided by 4. So 72 divided by 4 is equal to 18 radians per second squared. And because it's positive, it's correct, it's going this direction. And then if we look at the I component, minus AB, so this is equal to minus 12 plus by 6.928 alpha AB. Okay. So this will be equal to minus AB minus 12 plus by 6.928. Alpha AB is equal to 18. So this will be equal to 6.928 times by 18. 12 minus by this value is minus. Wait, is it minus? Minus 12 plus by 6.928 times by 18 is equal to 112.704. Okay, so AB is equal to minus 112.704 inches per second squared. So this direction we assume is wrong, right? It should be going towards the right. So therefore, when you put this, you put AB is equal to 112.704 inches per second squared, and it's going towards the right. I do him first. It's not that I don't like you, okay? But yes, I assume it to be going in this direction. Okay? It should be positive. Yeah, it should have been positive. You're right. So I'm going to do the change. So if this is positive, so K cross I is positive. K cross I is positive, positive here. K cross J is negative, so this is negative. So this is 72, and then this is what? This is positive 4. So now this direction is wrong. So if you look over here, this will be what? Negative, yes or no? Thank you for catching that. So this is equal to negative. So this will be equal to negative 18. So my assumed direction is wrong for this case. So the right direction is going this way. Okay, so this is equal to 18 radians per second squared, and it's going in the clockwise direction. So we now look at ABI. So this is 12. This will be equal, this will be cancel. This will be minus. Okay. And I will do this again. This will be cancel. This will be minus. Wait. So my 18 now will also be minus. So from here, minus AB will be equal to positive 112.704. Am I right? Right. So AB is equal to my minus. So the direction is correct. Thank you for flagging up for me. Yes. Okay. Thank you. Next time, put up your hand earlier. Okay, I messed up. Okay. What you just seen down here. Okay, it's a very good problem. And what we learn here is whatever you do not assume, because when I was here, I was not sure at point C is my acceleration is equal to 0. Unless otherwise proven, then it's equal to 0. So what you just observed for the past, how long did we do this question? 1 hour. You just saw a professor panicking, and then just have to sit down and just like go back to what? Rules and what? Fundamentals. Are we clear? Okay, don't like, okay, I don't know what to do now. I'm going to say to Eugene, I'm going to assume this at 0, and that's my answer. Don't do that. Are we clear? Okay, next question. Now, if you have to go, you go. I'm going to stay here till I finish everything. Okay. The next question that I'm going to attempt is question homework 4. It's homework 4, question 4. Okay, it's homework 4, question 4. Now, homework 4, question 4 is not so innocent. Okay. So homework 4. Okay, homework 4, question 4. So if we look at homework 4, if we look at homework 4, question number 4, we have a system looking like this. Okay. Now this question again is kind of like tricky. Okay. And it took me a while also. So the bar is confined to move along a vertical and inclined plane. If the velocity of the roller is going down at 6 feet per second, so VA is equal to minus 6 what? Feet per second. And we are given over here, theta is equal to 45 what? Degrees. Determine the angular velocity and the velocity of the roller. So we have to determine, because it's going down, we have to determine what is our omega AB. And we also have to determine what is our Vb. Okay. Yes. Wait. Yes. So if we were to use instant